Welcome to the presentation on comparing explanations. In this presentation, I want us to really start thinking about using multiple perspectives to understand human behavior. So we've talked about these four different levels: proximate explanations, ontogenetic, phylogenetic, and ultimate explanations. And oftentimes students ask me, what's the real explanation for behavior? What's the real cause for crying? Is it because I got something in my eye, or is it because it flushes out foreign bodies, preserving our eyesight, increasing survival and reproductive success? And as you can kind of get a sense from my explanation, there is no one real explanation for behavior. When we think about behavior, we really do have to think about it from multiple perspectives. Some will be more relevant in certain contexts than others. Depends on the context you're considering, and it depends on the desired outcome of the explanation. What do you want to use the explanation for? So one area that's really seen a exploration of using these multiple different levels to explain behaviors are causes of disease. So we can think of diseases as products of defense mechanisms. For example, if you get pneumonia, a good defense mechanism is to cough it out. We can look at proximate cause. This would be a proximate cause, a cough, and we can look at the proximate cause of infection, the pneumonia bacteria that are in the lungs. And we can use ultimate perspectives also to understand disease. So the fact that we live in novel environments, we have a lot higher chance of cardiac disease due to the high levels of nutrients available to us, and therefore our ability to put on so much excess fat. Now we can look at genetic explanations, and we can look for certain genetic predispositions to heart disease. These genes might not have been selected out of populations previously because no one experienced heart disease. So these genes might just have been latent predispositions that are now triggered in novel environments. We can also look at our phylogenetic heritage and look at design compromises, such as bipedality allows us to carry food and babies and other objects in our hands, but it has required a redesign of the human spine that makes us more prone to lower back pain, lower back problems throughout our lives. And other evolutionary legacies, like the design of the throat and the respiratory system, because our voice boxes have been moved up higher in the throat to allow for speech. Now, in order for food to reach the esophagus, it has to cross the respiratory tract, making us liable to choking. Now, very young infants can't choke because the voice box has not moved into the position for speech yet, so they can both breathe and swallow at the same time. However, for adults, this quick fix to allow us to be able to speak has also allowed us to choke. A better design would be to have the nostrils in the throat below the esophagus, but we can't go back and redesign the entire human face. So when we look for the causes of a particular disease, we have to understand what's causing the symptoms, what's causing the disease, and how to react to it. And this, of course, requires multiple perspectives. And if you're interested in this more broadly, I'm basically discussing what we call evolutionary medicine, and this is applying evolutionary theory to understanding disease. And evolutionary theorists who study medicine, particularly in humans, really do have to use all of these different perspectives. And both of these books are a great read if you are interested in these topics. I've gotten most of the information about allergies that I'll discuss next out of this book on the left, Why We Get Sick. Great, simple, quick read with lots of interesting information. So let's talk about allergies, and let's talk about four different levels of explanations for why we get allergies. Now, proximate or easy, what are the immediate causes? Well, are there allergens present in your current environment? I've been suffering from allergies throughout this entire course, and I assume because there's something blooming in Boise that is affecting me. Now, one thing that you can do to mediate the effects of these allergens is to take antihistamines. So if you don't have any antihistamines in the house, you're more likely to suffer from allergies because you can't minimize the symptoms. An ontogeny perspective looks at the development, and there's two ways we can look at this. We can look at your developmental environment. Now we know that growing up in certain environments can buffer against responses. Most people have lower responses to allergens in the environment that they grew up in. We'll talk about the hygiene hypothesis in point 4, but this basically looks at the developmental environment and your exposure to both allergens and to the antibodies that react to them. Also, ontogeny involves cultural learning. So some people have learned culturally that antihistamines exist, and here's how you take them, and these can dampen your symptoms. You're not born with the knowledge of how to take allergy pills. We can look at a phylogenetic explanation, and we can look at this allergenic response to remove foreign substances from the body as part of our species history. All primates produce immunoglobulin E, which is the antibody that produces the immune response to allergenic substances. And we have inherited this from our primate ancestors. Now, the ultimate level question, this is the most interesting one in my opinion, obviously as an evolutionary scientist, and is actually unknown. So the function of these immunoglobulin E antibodies are not known. These are what cause the immune response to allergens with itching and scratching and mucus production. And there's been several hypotheses stated. Perhaps they're a defense against parasites. The interesting thing about allergies is that it's a very quick response. In about 8 minutes after exposure to an allergen, you're producing an immune response. It's very, very quick. So this might be to buffer against parasites, both intestinal, like worms, and ectoparasites on the skin, like ticks and chiggers. So it might be some response to discourage them from taking advantage of our human body as their environment. I'm going to skip ahead to toxin response. This is also a potential response to toxins. When you encounter foreign substances that could potentially cause damage to the body, it's very useful to have a quick response. And in fact, a lot of people have an allergy to shellfish, and shellfish, because of their feeding behavior, often do have higher levels of toxins that we could ingest when we ingest shellfish. So the hypothesis is that it might be a response to toxins that would increase your survival success. The last is called the hygiene hypothesis, and this is a hypothesis stating a false reaction to novel human environments. And it goes like this: when children are little, through most of human history, they were exposed to a lot of parasites, bacteria, viruses, things that could potentially harm them, and their immune systems were ramped up to expect to have to deal with all of these diseases. The hypothesis goes that when kids are raised in very, very clean environments, they still have this reaction to foreign substances, but it begins misreacting to things like dust, which aren't so dangerous. So this hypothesis states that because we're raised in such clean environments, we're seeing a misfunctioning of this IgE antibody system. Now, which of these explanations is the most important? Well, it depends. If you're having an allergy fit currently in this moment, your immediate response is probably going to be to go where the allergens are not present and take some allergy medication to quell the immediate symptoms. It's also useful to know what we can do to our environments through the course of human development to reduce allergenic response. And it's also very useful to know what we can do to decrease allergenic response in general, because allergies have increased about tenfold in terms of who experiences severe allergies in the last 100 years. So they are becoming more of a concern for humans in the present day. A few things we have to cover before we can end this lecture series. We have to understand what we are not saying about humans using an evolutionary perspective. We are not saying in this class that using an evolutionary perspective allows us to make value judgments on human beings. Understanding why some people might have a susceptibility to heart disease or allergies or cancer doesn't mean that we should sterilize these people and not allow them to breed or deny them marriage rights or in other ways try to change the course of human evolutionary history. this is not what we're saying. We're just trying to gain a better understanding of things like disease and behavior. So the goal in medicine has always been help the sick, not the species. We're not going to let people suffer and die because it's not for the good of the species. And this brings up an important concept that I want you to keep in mind, especially as you talk to other people who are maybe not so familiar with evolutionary theory. And this is called the naturalistic fallacy. The naturalistic fallacy states that because we observe something in nature or as a product of natural selection, that's the way we should be. This is the fallacy. Fallacy means lie. So we should not be saying this. So my favorite example is the paleo diet. The paleo diet states that we should only be eating things that humans ate in the Paleocene. So basically from our hunter-gatherer past. And since this is the natural diet for humans, we shouldn't be eating other things like dairy products, grains, legumes, and vegetable oils, for example. Now, one of the things that we did discuss in this class is a gene culture coevolution that has produced a tolerance for lactose digestion as adults. And this means that eating dairy products is actually part of the human evolutionary history for some populations, but not all. And if you take this even a step further, modern medicine, like penicillin, is not in the paleo diet. Does that mean we shouldn't be using penicillin? Of course not. What the naturalistic fallacy is a lie about is that it's stating because we observe something in nature, it's good. We describe it as morally better. And there's absolutely no connection between a moral system and products of natural selection. We are not saying that it's possible to breed a better human. Better is defined by our code of morals. Natural selection is just simply genetic accounting. So we can't say because something is a product of natural selection it's good. We also can't say because something is a product of natural selection that it's bad. We can't make any moral judgments on evolutionary explanations. We're just stating that these behaviors, these disease responses, are present in current populations because they increase survival and reproductive success in the past. It has absolutely nothing to do with our moral code today. So this is a picture of my sister and her son, my nephew, and my sister has a genetic predisposition for cancer, and she has passed it along to her nephew. My nephew, her son. And I don't think anyone is suggesting that because we've decided that having cancer is a bad thing, we shouldn't let my sister have kids. So just keep in mind, if you do discuss the material in this class with other people, that they might have this perspective that when you say something is a product of natural selection, you're also suggesting that that's the way things should be. And this is just not the case. We're just stating that this characteristic as a product of natural selection is a product of genetic accounting. So we're not saying that because this is the way something is, it ought to be that way. We can't make any judgments. So how do we compare these different levels? As I said, what do we want to use the explanation for? We know that multiple explanations are not mutually exclusive. Think of our discussion of allergies. And also, evolutionary explanations require careful consideration. We had a discussion of human behavioral ecology and evolutionary psychology. One measures the outcome, the adaptive outcome of behavior. The other looks at the mechanism that produces it. Both require careful consideration about what we can say about these hypotheses, and also what other people might interpret the outcomes as, and how we interpret the outcomes ourselves. Because this concept of evolutionary theory is very fraught with misunderstandings in our society. So go forth, use multiple perspectives, and always remember to carefully consider evolutionary explanations for behavior. This is the last lecture. As always, thanks for listening.